Hello and good morning, everyone. My name is Muhammad Hakimi Akila Muhammad Hussein, and my matrix number is 207383.
Hello and good morning everyone. My name is Muhammad Bakhtiar bin Baharudin. My matric number is 205782.
Hello and good morning. My name is Muhammad Ammar Mustaqim bin Nur Anwari. My matrix number is 207736.
Hello, my name is Muhammad Adam Sabri. My metric number is 205663.
Hi everybody, my name is Kavishri and my matrix number is 206031.
Okay, so now I will start screen sharing. We're going to discuss about the translation question. Okay, so they give the sequence and then they're given above the transcript of the bacterial pal gene. The gene codes for pal, an enzyme that catalyzes the conversion of PHE to cinnamic acid. Underline the characters represent RBP and start codon. Okay, so the first question is give the amino acid sequence of the gene. Anyone would like to answer?
Me, I would like to try.
Okay.
Alright, give the amino acid sequence of the gene. So we start with AUG, right? Start codon until UGA. So the amino acid sequence is methionine, and then aspartic acid, and then glycine, and then glutamine, and then asparagine, and then aspartic acid, methionine, valine, and valine, and then stop.
Yeah.
Anyone different answer? No. Okay.
Yeah, I got the same answer. Okay, so now let's move on to the next question. Predict whether the transcript can be translated efficiently. Who would like to try?
Me. I would like to try.
Okay.
Wow.
I
See you
think,
again.
yes. Correct me if I'm wrong, but I think the transcript can be translated efficiently because the ribosome binding site RBS AGG positioned closer to the start codon AUG. Am I right?
Yeah, my answer is the transcript can be translated efficiently due to the presence of ribosome binding site that make it possible to have more ribosome bind to the transcript. And then the presence of RBS spacer also make the translation efficient.
RBS AGG.
Yeah.
Hmm.
Do you guys want to share your answer too? Adam?
No, I have the same answer.
Okay.
I also got the same answer as because the presence of the RBP. Yep.
Okay. Okay, let's move on to the next question. Predict what would happen to level of PAL enzyme under the following condition. Okay, I will answer this question. The first one is a deletion at position number 8. So if the deletion at position number 8 is right here, right? Here. I think it's here, right?
Yes.
Okay, so if there is a deletion here, we can still have the AGG sequence, right?
Yes.
It will not affect the RBS side. So I think for my answer is it will remain the same. The level of PAL enzyme will remain the same. Because it will not affect the sequence because we still have the RBS here. So it will not affect the translation or transcription. Anyone got any other answer? No.
No.
Okay, so for the second, a deletion at position number 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, at here. So if we have a deletion at here, we cannot get any RBS anymore. So for my answer, if decrease, the level of PAL enzyme will decrease because it has no RBS site anymore, and then the translation cannot do efficiently, and the protein cannot be coding because PAL enzyme is actually a protein. So the PAL enzyme level will decrease because it will not translate it efficiently. Okay, so for the C,
Sorry, Kimi. Can you
yeah,
repeat? Can you repeat the
okay,
answer?
yeah. If we have a deletion at position 11, let's say it's here, right? So we don't have any RBS anymore. So the translation cannot be translated efficiently. The transcription sequence cannot be translated efficiently. So the PAL enzyme is actually a protein. So we know that translation is coding for protein, right? So if the translation cannot do its work efficiently, then the protein will not have the same amount as the efficient translation. Okay.
Okay.
Okay, so for the C, an insertion of U at position 32. Okay, somewhere here. My answer is decrease because it will change the amino acid sequence. Anyone get the same answer?
Same.
Yes, same.
Okay, for the D1, a deletion at
Because,
position 31. Yeah.
sorry, because the insertion,
Aduh, aku nak ni. Jangan tengok lagi. Mas.
Berarti
it will be a, will it be like a frame shift mutation?
I'm sorry.
Yeah, because it will change the, okay, at the position number, at position number 32, we have, for example, we have proline, right?
Okay.
At position number 32. But if it's insertion, it will become serine. So the chemical, the amino acid sequence will change the protein coding. And I think it will,
It's completely changing the coding, right? Okay.
yeah.
Okay, faham.
Okay.
Thank you.
Bati, are you okay?
Yes. Dah potong
Okay.
Letak.
Tak payah.
Okay, D, a deletion at position number 31. Okay, if we have a deletion at number 31, my answer is decrease because at 31 we have proline, and then if we have a deletion, it will become histidine or glutamine, and it will change the amino acid sequence fully. So it will disturb the level of PAL enzyme, and then it will decrease the level of PAL enzyme. So for the E question, a deletion at position 25 and insertion of G at position 30. My answer is decrease also because it changed in amino acid sequence. If you see, it will have two start codon. Yeah, here. It will
decrease.
be
For E, decrease.
AUG. It will be decreased. The level of PAL enzyme will be decreased because because the amino acid sequence will change. It will be methionine, and I think it will decrease the level of PAL enzyme because the sequence of amino acid has been changed. Okay. Anyone agree? So for the F, a deletion at position 23, it will decrease because it will also change in amino acid sequence. Okay. Anyone would like to, you guys get the same answer?
Actually,
Yes.
right. When they mention by the level of PAL enzyme, how do you determine whether if it increases or decreases? Because I mean, there is a change in the amino acid sequence. Okay, so what do you, how do you determine? Like, I get it, like it changes from one codon to another, but like, how do you determine?
Yeah, from my understanding, we know that translation is a site for protein coding, right? So actually, PAL enzyme is a protein. So I think I imagine like this, when we have a change. So for example, that we need to coding for PAL enzyme. So actually macam like asparagine, methionine, and valine are coding for PAL enzyme. But
Okay.
actually there will be a mutation, and then it will change the methionine to proline and methionine to histidine. So it will change the whole amino acid sequence that is
Okay.
basically will code for PAL
Oh,
enzyme.
okay. Yang. So basically, like when there's a specific gene that promotes the production, example of the PAL enzyme. So now, since the coding that changed, it will disrupt the production of the enzyme, right?
Yeah.
Ah, okay. Okay.
Okay.
Okay. Now I get it.
Okay. So if
Thank you.
we'll move on to the next question. Predict the size of the PAL enzyme under the following condition. Anyone would like to try?
Okay, for this question, I will try to answer, but if I'm wrong, help me. You guys
Okay.
can help me. Okay, for the first question, predict the size of the PAL enzyme under the following conditions. A, normal condition. So for this question, the size I put it in small, medium, or large, something like that. So for question 1, PAL enzyme is normal condition, which means it codes normally, right?
Yeah.
So I
Yes.
put it on a medium size. You just assume
Yeah.
in a medium size. Why? It is because the average size of enzyme is around 50 to 70 kDa.
Okay.
50 to
Mm-hmm.
70 kDa, and then the PAL enzyme size is also around 70 kDa, like 77. It is the average size of an enzyme, so I put it in medium. Okay, normal condition medium. So for the B, a deletion at position 8.
Yeah.
Okay, deletion at position 8, where? 10,
Somewhere
9, 8. A.
here, right?
So I also put medium because deletion at position 8 does not change the coding reagent. It only mutates.
At the
So
RBS.
at RBS. So it will not change anything like the codon causes amino acid. Then it will be in medium size. The same as question A.
Okay.
Okay. So for question C, a deletion at position 11. 11A. Also A. Okay, my answer is also medium size, which is no change in size. This is because the amino acid will alter the conformation of the enzyme in the tertiary structure. Enzyme tertiary structure or quaternary? Tertiary. I think
Quaternary, right?
Yes, quaternary.
quaternary hemoglobin enzyme
Yes.
tertiary, right? Wait.
Yeah.
Okay.
Hemoglobin quaternary.
Hemoglobin quaternary,
The
enzyme
enzyme
tertiary.
is quaternary.
And
Enzyme tertiary.
Quaternary also.
Huh?
enzyme is
Enzyme?
quaternary also.
Oh, okay. So it will alter the conformation of the enzyme in the quaternary structure. So it will cause it to be denatured. That's why different amino acids will change the enzyme. So it's still in medium size. So for question D, an insertion of U at position 32. Position 32.
Oh, sorry, Amar. Enzymes are tertiary structures.
Oh, enzyme
Yes.
tertiary.
sorry.
For
Okay,
the
for
C
the B.
question, kan? It will disturb the RBS, right? So don't you think that the translation will not be efficient? So it will affect the size of the PAL enzyme or not?
Oh, do you have any answer?
Makes sense.
I I think it's smaller, but I don't know
Mm.
because it changed the RBS side, so we don't have any RBS, and then the translation cannot be translated efficiently. So I put the smaller because
Smaller.
the translation is not efficient, but I don't know.
I think so.
Kimi.
Yeah.
So
Yeah.
since the RBS have apa deletion mutate.
Uh-huh.
So why do you think it is smaller? Like if there is any mutation, can it be larger? It cannot be larger because there is.
I think for larger, if we have the sequence that addition, but it does not change the amino acid sequence.
Because there is no addition.
Yeah. So I don't
Okay.
know if C it's smaller or remain the same because yeah, what Amma said makes sense because it doesn't really disturb the translation, but yeah, I don't know how we would like to
Actually,
justify.
I think because I read this, like, does mutation at the ribosomal binding site cause any interference to the production of the protein?
Mhm.
And apparently, it certainly does influence the rate of the translation. So I think I would agree with Kimi because initially I had Amar's answer where I thought because it's not disturbing the coding region.
Yeah.
So I thought it would not make any change, kind of. But then now, after Hakimi asked the question, I think it kind of does make sense. If there is a mutation in the RBS site, I think there would definitely be an influence to the production of the protein. Sorry, I mean enzyme.
Okay.
Okay, for the next question, question D. An insertion of U at position 32. Okay, so for this question, position U, position 32. Okay, I'm a little bit confused, but I think the size of pile enzyme will change into the large size. Why? For me, it will get bigger because enzymes are a tertiary structure of protein, right? When an insertion of U at position 32, it will have a longer sequence and longer chain of an amino acid. So when it is folded, when it is so longer and when it folded, so it will be bigger, more bigger. But to be safer, the size will change. But I don't know either big or small. So I think like that.
But Amar,
So
there's
you guys
there's a chance that we will get the stop codon earlier, right?
Yeah.
So
because we have
and then we have a chance that the codon code for the same amino acid, right?
Yeah, true.
So it can be same size or larger or smaller.
same size, larger or smaller?
Yeah, I think it should be one of these three answers also.
Yeah. We're not sure, but it can be changed or same, right?
I think the size will change at any moment.
Yeah.
True.
Okay, I think we have the answer. Let's move on. Next.
Okay, let's move on. So next question E, a deletion at position 31. 31A. Okay. frame shift mutation occurs, so the size of PAL enzyme will also change, either smaller or bigger because of a change in amino acid. So I
Yeah.
think it's changed smaller. Oh. So
Yeah.
for F, a deletion at position 25 and an insertion of G at position 30. 25.
Where is 25 and 30?
25
20,
and
25, 1, 2, 3, 4, 5,
22,
G.
23. Oh,
here, right?
start codon. Yes.
Oh,
So it will delete here, and then it will insert at position 30G here.
30, G.
So
Oh, so for
the
this
start
question,
codon,
So
this,
the start codon will change
will
to
not be the
the
start codon, right?
mhm.
so
will
the
be the
size will be the same.
Yep, I think the size will be the same also because technically we're not losing our start codon. We are just shifting
yeah.
the position of it. So I agree
It
with
will
Anna.
not affect the size of the PAL enzyme. Okay.
Because of no change in amino acid.
Yeah.
Yep.
So for the last question, a deletion at position 23. So for this question, the size of PAL enzyme will change either bigger or smaller because it alters the amino acid sequence.
I think it will be smaller. 22, 23.
Smaller.
Yeah, because it will alter the amino acid sequence. It will be the mutation somewhere 21, 20, 21, 22,
At
23.
A.
Yeah.
Yeah.
So it will disturb the stop codon and the start codon. So yeah, I think it will be smaller.
Thank you.
Okay. We have agreed at the question number 4.
Question number 5. The amino acid tRNAs that translate the following codons at position 23, 1007, and 1010. So, amino acid position 23. So, can I draw?
Yes.
Yeah, sure.
But you need to download the slide first.
No, it's okay. I just draw here. So can you guys see the circle? Okay. Okay, boleh kan? Okay.
Yes.
Yeah.
So here the position number 23 amino the position number 33 AUG. So AUG is the first. What is it? What is it? The explanation. Yeah. Okay, so sorry. The amino acid tRNAs translate the codons at position number 23, 1007, and 1010. So so position number 23 is the AUG, the start codon. But when we look at the position at number 1007, it is also an AUG.
Yeah.
This one. So, but both of them did not have the same name because the first AUG is closer to the RBS, and the second that, and also it is the first one, and also this AUG is the apa, another AUG in the energy AUG codon. So
Just
the
according
first
for
AUG
methionine.
name yeah. The according for methionine. Thank you. So the first AUG is FMET tRNA MET, and the second AUG is MET tRNA. So allow me to share. Okay, this one. So the explanation from the lecture note. So the first one, the first AUG is closer to the RBS. So it is FMET tRNA MET, and the other AUG codon is the MET tRNA MET. So MET is self-explanatory, which is methionine. Stands for methionine. And then, okay, do you guys get the same answer?
Yes.
Yes.
And then question number 6, explain how this valine position, position number 10, 10. Sorry, so 10, 10 is
Valine tRNA.
GU, is it? Valine tRNA. So, and then question number 6, is it the same too? You guys get the
Yes.
same too for position 10, 10. Okay.
Yeah.
Yes.
So, question number 6. Explain how this valine tRNA THR avoid the codon position at 10, 10, position 10, 10. So, I try to explain. So, how does valine tRNA THR avoid? This is because of the fidelity of codon, I think, fidelity of the translation.
Uh-huh.
I think the, where is
It
the
has somewhere in the
explanation?
slide.
Yeah, I think it is because it is
because the
hydrophobic.
valine. Yeah.
Hydrophobic site, they prefer valine codon rather than, I'm not sure what is the, so valine
Rather
codon
than
is the
threonine.
threonine. So valine codon itulah it is position number 10, 10 GUC, is it GGU,
Yes.
right? Okay,
I get the same answer also.
that's how they avoid the codon at position number 10, 10. So they at position number. So do you guys understand?
Yes.
Yes.
Because
Yes.
I'm sorry for the lack of explanation because I just understand just a little bit about it. So if there anyone that would like to explain further about it, so please do so. So yeah.
Okay, actually for number 6, the valine tRNA transferase has two adjacent catalytic sites. So the first is synthesis site, which is valine attached to the tRNA, and this site is hydrophobic. So that's why valine is preferred than threonine. So that's why the valine will be the codon rather than threonine because of the synthesis site and the hydrophobic.
Yes. Okay.
Okay, let's now move on to the next question. How many ATP equivalent is required to translate this transcript?
I would like to try that question.
Okay.
If you see, the formula to find for ATP equivalent is 4n minus 1. So n referring to the number of amino acids. So now if you see from the start codon until the stop codon, you have sorry. What Okay. So from the start codon until the stop codon, you have 1016 amino acid, 1016 amino acids. So what? Sorry, not amino acid. What do you call this? Codons.
Sequence.
Codon.
1016 codons. So what are you gonna do? You're just gonna take 1016 minus 23. We're gonna get 993 codons. But that 993 codons is inclusive of the stop codon also. So when you wanna get the ATP, this one you don't have to include the stop codon. So what do? We minus it off with 3. So we get 990 codons. That if we want to make it into that 990, we divide by 3, we get 330. Because each sequence has 3 codons, right? So 990 divided by 3, we get 330. That is the number of amino acids we have. So what are we going to do is we're going to take 330 and substitute into n. So 4 times 330 minus 1, you will be getting 1319 ATP. Did you all get 1319 also?
I get 1324. I use a different method.
What method did you use?
Okay. Let me share. This is my answer. So I do some research about the translation energy requirement. And this is what I found. Okay, so for translation, we need to divide it into several categories: amino acid activation, initiation, elongation, termination, and then we need to the total of the ATP. And then, yeah, for the first one is amino acid activation, which is charge the RNA. It requires 2 ATP, which is ATP will be hydrolyzed to AMP plus pyrophosphate, and then hydrolyzed again to 2 inorganic phosphate. So that's why it has 2 ATP here. And then for the initiation step, it requires 1 ATP because the GTP will hydrolyze to GDP and plus 1 inorganic phosphate. So that's why it requires 1 ATP. And for elongation, it requires 2 ATP because 1 GTP is for elongation and then 1 GTP is for translocation. Okay, and then D is termination. It requires 1 ATP as GTP hydrolyzed to GDP and 1 inorganic phosphate. Okay, so from the sequence, we get 1015, and then we need to minus 23 because of the RBS and whatsoever at the front. So we get 992 codon, amino acid codon.
Right. I'm so sorry. I Ahmad. Sorry. Tadi Adam. Tadi I cakap it's 1015. But I think you will eventually get the same answer because it goes into a decimal. So if you round off, it's still technically 330, but it's not 1016, 1015. Sorry, Hakimi. Sorry.
Okay. Okay. So and then the 992 we will divide it by 3 because codon contain 3 base pair, right? So we'll divide it into 3. So we get 330.7, and then we approximately it will get 331. And then we have 331 amino acids in line, right? So we have to total it up, and then we get the, okay, at the here 331 times 2 because of the activation process here. So we need to multiply 2, and then we get 662. For the initiation, it has 1 ATP, so only 1. And then for elongation, for the initiation, it does not affect any codon. So we're not gonna take the amino acid sequence. So for the elongation actually, they said that we need to minus 1 because we only have 330 elongation. So for example, we have 29 amino acid. We only need, for elongation, we only need 28 amino acid. So that's why we take 330.
I actually saw this example is because they say, why are we only taking 330 is because we are already starting off with 1 amino acid and we are additionally adding 330 amino acids. So that is the amino acids we need to calculate. So it's 330. Yeah, got it.
So we get 660, and then for the termination, termination is does not, because stop codon has its own, so it does not affect the translation, and then it is 1 ATP, and then we total it up, we get 1324 ATP. I don't know if it's true or not, but I found this on YouTube.
I watched the same YouTube and I got the same answer, 1324. And then when I checked around with some of their friends, some of my friends, the formula they used was 4n-1. So now technically
I also have 4n-1 formula too, but I don't know which one to use.
Same, so now I also have 2 answers that I don't know what to do about.
Because the 2 formula give 2 answers, so I don't know.
Maybe what we can do for now, we can keep these 2 answers, 1319 and 1324, and maybe we can check with the lecturer. We can check with our lecturer in the next class, see what he thinks about the formula.
I think we can do that. Okay.
I think moving on to our last question.
Okay.
What is the question again?
The question is, what size of this transcript?
What's the size of the transcript? Is we are gonna take the entire size, the whole nucleotide. So we're taking 1015 nucleotides.
Yeah.
So it's the whole thing.
I get the answer too. Okay, anyone has clashed answer or anything?
Everybody okay with all the 8 questions?
Yes.
Okay, okay.
Yes.
Okay.
Everyone okay with all the question?
Yes.
Yes.
Okay,
Yep.
so we have discussed about the translation question, and I think we have get the answer for this question. So I think we will stop here. And thank you, everyone.
Thank you.
Thank you.
Thank
Thank
you.
you.